Hello and welcome back. It's puzzle time with Sudoku Sleuth, and today we're looking at setting boundaries. I mean, explicitly, the name of this is called setting proper boundaries. And you can see, well, what I hope isn't Sleuth in the thumbnail here, with a lady over what looks like some kind of dinner date, dinner lunch, having clearly a discussion about boundaries, which is why Sleuth is looking so miserable and forlorn. Now, just a piece of advice for the guys. Don't look as miserable as that when you're having such a conversation with your partner. You definitely need to. It's healthy as part of any relationship. And I guess for the ladies out there, just accept that most of us guys just have the emotional maturity and depth of a teaspoon. So don't be too surprised if any kind of difficult conversations we end up looking pretty much like this thumbnail. Yeah. I'm just going to say that no, this is definitely not Sleuth. This is not me in the picture. This has never happened before. So, quickly moving on, let's take a look at today's puzzle. It is setting proper boundaries by willpower. And I'm guessing this sort of kind of cage-like thing, not cage, but, you know, almost like a wrestling ring, is the boundary, and there's a lot of things happening in the middle, and it's kind of true. Well, let's take a look at the rules to try and understand what does it all mean. So we've got normal Sudoku rules apply, so that means the digits 1 to 9 in every row, in every column, and every 3 by 3 box. Numbers on blue and orange lines are odd and do not repeat on each line. So essentially what I'm interpreting this is, this is 5 cells long, is these are the numbers, are odd numbers, and because they are not repeating, they are the digits 1, 3, 5, 7, 9 in some order. And that's true for this orange line, this orange line, this blue line, and this blue line. Okay, that's fairly straightforward. Numbers in cages sum to the number in the top left corner of the cage. So this 6, for example, these 2 cells, if it's, let's say, a 2, this would have to be a 4 to sum up to 6. The 15 is duplicated in its cage, so this 15 cage, because the orange line can obscure it in some puzzle formats. Well, it doesn't seem to in our puzzle format, but ignore that 15. Essentially, these 3 cells must sum up to 15. And let's see what else. The 2 pink cells bordering the long ends of each 3-cell cage also sum to the number in the top left corner of the page. Of the cage, excuse me. So essentially what that means is these 2 cells also sum up to 15. These 2 cells sum up to 12. And I guess these 2 cells sum up to 14 and 12 again. It's an odd way of showing it, but I guess it makes sense. It'll be very tough to try and draw a cage around it, but not including the 3 cells in the middle. What else does it say? Numbers with a black dot between them are in a ratio of 2 to 1. We've got a few of these, a few of those as well. So, for example, if this is the digit 2, this would have to be 1 to be 2 to 1 ratio, or 4 to be in a 2 to 1 ratio as well. And not all possible dots are given, so no negative constraints apply. Well, that's a fairly straightforward set of rules. And if you feel like having a conversation about proper boundaries, I can't imagine many of you necessarily volunteer for them, but link will be in the description down below for you to play along as usual. And with that said, let me restart the clock and see how I get on. So when I was going with this killer cage example, it was so obvious that this is not a 2-4. So there's only 2 ways of making a 6 in a 2-cell cage. It's either 2-4 or it's 1-5. Now, given this cell, because it's both on an orange line and a blue line, it must be odd. It's clearly not 2-4. So this is a 1-5 cage. Which doesn't leave many options for the 10. And the thing is, because this is odd, this is also odd to get to 10. You need two odds to get to an even. So I've removed 1 and 9 from the equation. The only other remaining odd pair is 3, 7. 2, 8 is even, 4, 6 is even. It can only be a 3, 7. I'm going to say, because we need an odd digit here, and we've already pencil marked 1, 3, 5, and 7, that can only be a 9, and all of the rest are now even from 2, 4, 6, and 8. Except we need to lose one of these, the 8, to make up a 12, and that's the 8 here, that's the remaining even digit in box 4. That's a fantastic start. It's quite unusual for a willpower puzzle to be going that smoothly. So we can see that the 9 now is on all of these cells, and therefore none of these are 9. Having said that, these are odd, and they must add up to 12. So it's either 3, 9 or 5, 7, 8, 4 won't do. And there's no other way of making 12 in 2 cells. So it could be 3, 9 with 9 and 3 up here, or it could be 5, 7, very much dependent on what's going on there. If this is 7, this would be 5, and that's actually fine because this would be 3, this would be 1, that's all okay. Just seeing if we have enough information to solve it already, but I'm not really sure. And sorry, if this is 7, this will be 5, yeah, this will be 1, this will be 3, that's fine. And I guess the reverse is also fine, isn't it? 5 and 7, yeah. It's just highly likely this will be a 1. And if this is 3, 9, it really exerts no pressure whatsoever on here. Okay, let's move on. 15 cage. So this is an odd digit followed by a black crop key dot that is almost certainly 2 evens. And why do I say that? Because you're multiplying by 2, so one of these at a minimum has to be even. If one is odd, one is even, we won't be able to get to 15 because we've got odd, odd, even. That will sum up to an even digit. So it has to be an odd with 2 evens, so 3 is not part of this solution. Now if this is 1, 2, as in 3, this would have to be 12, clearly not going to work. I said 3 is not part of it, 1 is not part of it, again because it's an odd digit. 2, 4 would be a 6, and this would be a 9, so that's actually plausible. 2, 4 I said, with a 9. Yep, that's plausible. The next one up would be, I guess, 4, 8, because we can't do 3, 6, so 4, 8 is 12 with a 3. Also plausible. So this is 2, 4, 8 with definitely a 4 in here, and definitely not 4 in there. We still need these 2 to add up to 8. Which is, 15, which is either 6, 9 or 7, 8. This is starting to feel extremely restrictive. Is that even possible? So 2, 4 would require a 9, making these 7 and 8, and this would be 6. So we've done 2, 4, we've done 6, we've done 8, we've done 7 and 9. Therefore, this would be 3, and this would be 1 or 5, neither of which is used. So this could be 1 or 5 as well. Now, the other version of this is 4, 8, with a 3, with a 6, 9, and incredibly, 7, 2, and again 1, 5. Wow, okay. So these 1, 5s are opposites, whatever they are. Now this is, well, if it's 8, this is 4. If this is 4, this could also be 8 or a 2. This could even be 4, 2, and then back down to 1. So that's, yeah, this is not helpful, pencil marking this. Where am I going next? There's an extraordinary number of options on so many of these things. So this could be 2, 4. It's not 1, 2. And it's not 4, 8. It could be 2, 4 or 3, 6. And in fact, so is this cell. The 12, if this is odd, that means there is another odd with an even. I'm missing something. It shouldn't be this hard. What am I missing? So here is something interesting. These are different. I've also got 9 on here. So this is not 1, 5, or 9. This is 3, 7. And therefore this is 3, 7, or 9. And look at that. We've got a triplets of odds in column 5. Now a 9 would be joined with 1, 2. There's many ways of doing this. I think what I really need to figure out is these odd digits. I've got to do something useful with them. So 3, 7, 9. We've done a triplet, which means 3, 6 is not available here. There's still so many options. I haven't made any mistakes, have I? That's 6, that's 10, that's 12, that's a solid 9, so that's not a problem. I don't want to go down, I suspect I will need to start coloring some of these, but I don't want to go down that route just yet. We do know that this is 14. There you go, that's helpful. This can't be a 3, and therefore this can't be a 9. This is a 5, 7 pair. And if this is 5, this is 9, and it cannot be 7, because that can't be another 7. That's 5, that's 7, that's 3, that's 7, that's 1, that's 5. 7 removes 7, 8 as an option to making 15 here in the middle. There's a 6, 9, meaning that's not 9, that's got to be a 3, and that's got to be joining the 4, 8 to get kind of close to being large enough. That's got to be a 2. And this has to be a 9 to join the 5 to make 14. That's a 7. That's a 9. That's a 5. Wow. Just needed to pay attention, but as soon as you do, you've basically cracked it. Look at this. We need 1 and 5. We've got a 5 here telling us the order. That's the 5. That's the 1. We need a 1 somewhere on this line. It can't be either of these. That's the 1. We now need 3 and 7 to finish off this line. We need 1 and 3, both of which are possible, to finish this line off. This is the 3, that's the 1, that's the 3, that's the 7, that's the 3, that's the 5. This has to be 1, 2 to join the 9 to make 12. I need 7 and 9 in here, which incredibly, no, it is resolved because of this 9. 9, 7. That's the boundaries established, a proper boundary nevertheless. So these two cells, this cannot be 9, 3. This could be 8, 4. tend to say it can't be 5, 7, but I think it can be. This could be 5 and this could be 7. So that's actually plausible. So, am I going to pencil mark this? Probably not. I mean, that's not 3, that's not 6. Yeah, go on then. That's 5, that's 7. Or it could be another 4, 8 and another 4, 8. Okay. This 4, 8 is from 2, 4, or 8. We've got this 9 here telling us that this is the 6, and therefore this is the 9. We need to finish this off with a 2, and then a 4, 8. So 2, 4, 8, except this is not an 8. We need a 1 in this row. It can only be in there. We've basically done all of the odd digits, so it's only evens that are left in here. And it's really basically any of them, for this set at least. Okay, 2 or 4 can't be a 1, could be 2, could be 4, could be 8, technically. We'll think about that in a moment. And if it's an 8, we need to get to 6, except 1 and 5 are not available. So it would be 2, 4. If that's a 4, we need to get to 10. 1, 9 not available. 3, 7 not available. And if it's 4, 4, 6 is not available, so 2, 8 it would be. If that's 2, we need to get to 12. 9, 3 not available. 8, 4 would be one option. And 7, 5 is not an option. So this is a 2, 4, 8 triplet, as incredible as that sounds. And now we need a 6 somewhere, and 1, 3, and 7. I don't really want to pencil mark all these options just yet. So I'm just going to have a look around, like, we've got a triplet in here now. We need a 5 in this column, and it can't be in these two cells, so that's the 5. And this is now a 6 and a 1, I assume. That 1 tells us the order. That's the 6. Lovely. We're still left with a very odd setup of 4, 7s, and 8s in here. 4, 7s, and 8, except 9 of these are 7. This is the 7, and therefore this is the 5 to get to 12. Got 4s and 8s. That's not a 4. I guess therefore that's not a 2. 4, 8 pair gives us the 2, neither of which now are 2. Unfortunately, 2, 4 and 4, 8 are both possible here. Now 2, 4, 4, 8 both would use up a 4 in these two cells. That's not a 4. Not a huge amount of information really, but I'll take it. Eight, 4, 2, is that really possible? 8, 4, 2, no it isn't, because that breaks this cell, which is only 2 and 8. So, can this actually be a 2? I think the answer to that is no, it can't be. So this is 4, 8. This is the same cell actually, excuse me. This is the same value, whatever it is. It's either 8 or 4. We don't know what it is though. Okay. 4, 8, that's not a 4. Therefore, this is another 2, 6. I'm kind of looking at this and thinking, surely I have enough information, because aside from having something to break this 2, 6 outside of this box, it's all fairly well self-contained at this point. What do we have in here? It's a 9. No, it's not. 1, 3, 5, 7. That's the 9. That's the 6. This is not 3, 6. We knew that already. This is not 3, 6. So this is helpful because this can only be, because it can't be 1, it can't be 8. can no longer be 3, 6. So this can only be 2 or 4. 2 can still join a 1, a 4. The 4 can still join a 2 and an 8. That's quite frustrating in that it's basically every option here. So what clues have we not used? I'm guessing I just need to pay more attention to Sudoku, such as these 5s, telling us that there is a 5 in here and a 5 in there, and that's all the 5s done. 1s maybe. So one of these is a 1. And one of these is a 1. 1, 2, 1, 2. Yeah, this can still be 2, 4. It's not a problem. Right. Not going to resolve that. 3s. There you go. That tells us the order of this. That's nearly all. That is all the 3s done. We've done 5s, 7s. I think, although, yeah. Okay, 9s. There we go, that gives us the 1s as well. Whoops. Did I do this correctly? I'm pretty sure I did. Yep. And that's all the 9s. Yep. So that's 9s as well. So this is 1 or 6. Do I know the order? No, I don't. Of course not. Have I done all the odds? No, there's still that 7. But pretty much otherwise. So this is 2, 4, or 8. There's an 8 in here. It can't be there. This is in fact a known digit. This is a 2. This is an 8. This is the 4. Therefore, this is a 2. This is 1 or 4. I need, I'm guessing, 1, 4, or 6. This is 4 or 6. And I know what this digit is. That's it. I was going to say that's a 2 to finish it, but that's not true. 8. We need here 6 and 8, it seems. We need there 7 to, I need one more digit, 4. So 2, 4, 7, that's not a 4, we've got a 4, 8 looking at it. We said that wasn't a 7 with our earlier pencil marks. So that's 2, 4, and that's unfortunately 2, 4, 7, that's all of them. Right, I'm clearly missing something that will help me just really finish this off. I clearly need to think about this black crop key, and since I don't really want to pencil mark all the rest, let me at least just finish this off. This is 1, 4, or 8, and all of which are possible. So can this be an 8? Yes, this can be a 4. Can this be a 1? Yes, this could be a 2. And 4, this could be an 8. Can't be an 8, it can't be a 2, because that would be 4, 2 breaking this cell. So that's not a 4. Not huge consolation really. That's 2, 4. That's a 2, 4 pair. And we've got a 1, 6, 8 triplet. So we need so many options still. What did I miss? This is from 267, all of which is available. So this is 2467. Come again, I'm definitely missing something. Right, if these are both 4s, that's a 4, that's a 2, that's an 8, and that's a 4. Yeah, all of that sounds good. If these are both 8s, that's a 2, that's a 4, that's an 8, that's a 6, that's a 4. I always seem to put this as a 2, that can't be right. If they're both 8s, that's 2, that's 4, so yeah, this would be 2. Both of these are 4s, that's a 2, that's a 6, okay. It's not that. It's not this 267. Is it really this last cell? 6 8s. 1 6 8 triplet. That's not a 1. Got a 1 looking at it. That's 4 or 8. Still no. There you go. If that's a 1, this would be 8. This would be 4. What would this be? So this can't be 1. This is a 4. This can't be the way that you're meant to spot this. I must have missed some other logic. But, you know, I'll take it. So this is 7. What is this? 4, presumably. 4 and 8 are both looking up here. That's a 6. That's a 2. That's the 7, 2, 4, 8. That's given us the resolution that we need in here. And if I've not made any other mistakes, that's a solution to today's puzzle. It's a lovely puzzle, Mr. Willpower. Kind of just surprised by the ending. It was going all so smoothly until I just had to sort of essentially really pay attention to some of these black crocky dots. So maybe there's another trick here that I missed, and I'm sure if I have, there will be a comment about it in the description down below that somebody will point out to me. But I hope you enjoyed today's puzzle and today's video, and I'll see you back for the next one. Bye for now.